I needed to convert several long-form text documents, essentially full audiobooks, into high-quality spoken audio. My goal was to produce about 2 hours of audio per document, and I wanted this process to be entirely automated. I'd explored several text-to-speech options before, but ElevenLabs consistently offered the most natural-sounding voices, which was critical for something as long as an audiobook. The challenge wasn't just calling their API, it was handling the sheer volume of text, ensuring voice consistency across many separate API calls, and keeping the cost manageable. I quickly realized that simply pasting an entire manuscript into a single API request wasn't going to work, both due to ElevenLabs' character limits and the practicalities of managing network requests for such large payloads. This led me to design a system specifically around chunking the input text into manageable pieces. My first step was to build a robust text preprocessor. I wrote a Python module, TextSplitter.py, that would take a raw text file and break it down into smaller, logical segments. The primary function, split_into_chunks text, maxstars equals 4000, aimed to keep each chunk under ElevenLabs' 5000 character limit, but I used a slightly smaller buffer to account for potential formatting changes or minor expansions. Crucially, it tried to split on natural sentence or paragraph breaks using NLTK.sentokenize and by looking for double new lines. If a single paragraph was too long, it would then split mid-sentence as a last resort, though this was rare. Each chunk was then fed into a queue for audio synthesis, ensuring that no single request was too large and that I could resume processing if the pipeline ever failed midway through a chapter. Selecting a consistent voice was another key concern. ElevenLabs offers a wide range of voices, and if I simply used their default or a random selection, my audiobook would sound like a chaotic mix of narrators. I wanted a single, authoritative voice. I spent some time in the ElevenLabs dashboard, previewing different voices and eventually settled on one I liked, identified by its unique voiced. This voiced then became a hard-coded configuration parameter in my config.py file. ElevenLabs voiced equals 21M00TZCSI-W4XPTKC. By centralizing this, every single API call for every single chunk of text would use the exact same voice, maintaining narrative consistency across the entire 2-hour audiobook. This simple step was vital for a professional-sounding output. The core of the system was the ElevenLabs client class. I built this to encapsulate all the API interaction logic. It took the ElevenLabs API key and the voiced during initialization. The most important method was Synthesizing text chunk output path. This function handled the actual post request to the https://api.elevenlabs.io/v1/text-to-speech/voiced endpoint. I included proper error handling, logging any API-specific errors or network issues. Importantly, it wrote the binary audio data directly to the specified output path as an MP3 file rather than holding it in memory, which prevented memory issues when dealing with hundreds of audio chunks. For managing the audio files, I established a clear directory structure. Each book or document got its own folder, and within that, chapters were subfolders. Inside each chapter folder, individual audio chunks were named sequentially: Chapter 01 Chunk 001.mp3, Chapter 01 Chunk 002.mp3, and so on. This made it incredibly easy to track progress, locate specific segments, and, critically, to concatenate them later. The naming convention was handled by the orchestration script, ensuring consistency. After all the chunks for a chapter were synthesized, I used PyDub to concatenate them into a single chapter 01.mp3 file, and then the individual chunk files were deleted to save disk space. Cost was a significant consideration for generating 2 hours of audio, which translates to a substantial character count. ElevenLabs charges per character, and I needed to be precise. I tracked the character count for each synthesized chunk and maintained a running total. My target voice, which I found to be high quality, cost about $1.00 per 18,000 characters with my subscription tier. For a 40,000 word book, which often translates to around 200,000-250,000 characters, I was looking at approximately $15-20 per book. With an average speaking rate, this worked out to roughly $0.35 per hour of generated audio, which for the quality I found to be quite reasonable for automated production. Putting it all together, my main orchestration script, generateaudiobook.py, tied these components together. It read the input text, called split_into_chunks, iterated through each chunk, called client.synthesize_chunk, and then managed the concatenation. I also added a simple SQLite database to log the processing status of each chunk, whether it was pending, synthesized, or failed. This meant I could stop and restart the script at any point, and it would pick up exactly where it left off, only processing unsynthesized chunks. This was crucial for long processes that might take an hour or more to complete, minimizing wasted API calls and time. The final output was a series of perfectly narrated MP3 files, one per chapter, ready for further post-processing like adding background music or sound effects, which is a step I'll cover in a future video. This automated system allowed me to generate high-quality audiobooks from raw text with minimal manual intervention, drastically reducing the time and effort required. I've used this exact pipeline to convert several of my own long-form articles and even some draft book chapters into audio, giving them new life and reach. If you're tackling similar projects or want to see the complete codebase for this ElevenLabs integration, I'll be releasing the GitHub repository soon. Consider subscribing so you don't miss that, or my next video where I'll dive into dynamically generating chapter art with Midjourney for these audiobooks.